Good morning, or afternoon or evening, wherever you are. Welcome to video number 19, Mastering the INCOSE System Engineering Handbook in preparation for the INCOSE System Engineering Professional Exam. This is video number 19, Risk Management Process, from Chapter 5.4 from the INCOSE System Engineering Handbook. My name is Lance Sherry, and I'll be your tour guide for this short video. For those jumping into the series in the middle, just a little bit of background. We, as system engineers, build complex systems with lots of components and, more importantly, lots of interaction between the components, resulting in complex systems. And we build and deploy and operate those systems in very complex life cycles. So suffice to say, system engineers have their jobs cut out for them. And to manage that complexity, the INCOSE System Engineering Handbook has a set of practices, processes, and activities to help us through. So it is so complex that there are 59 system engineering lifecycle processes and activities that are identified in the INCOSE System Engineering Handbook. And those 59 processes and activities are organized or categorized into 7 groups. So the topic of this video is technical management processes, and very specifically the fourth one in the list of risk management process. One more piece of context. The system engineers organize our work to create, upgrade, retrofit systems into projects. So that's the unit of measurement is something which we call the project. And the technical management processes, all 8 of them, are designed to build plans to create, upgrade, retrofit systems, to monitor the progress of the development and operations, and then to manage and control in the event that there are things that are not going to plan. So this group of activities is associated with the projects, the project plans, and then executing the project plans. So the learning objectives for the risk management process is, number 1 is to establish the purpose of the risk management process, and then 2, 3, and 4 are the outputs, inputs, and process activities. So the remaining 5 through 9 are a definition of terms, and then also information or knowledge about the types of project risk that can occur, the sources of project risk, risk management analysis approaches, how to go about identifying risk in project plans, and then how to treat project risks. So one important point that's made at the bottom of this slide is that there's a big difference between project risk and product risk, and that's something that sometimes system engineers confuse. The purpose of this topic, risk management process, is to do with managing the risk to the project. So let's jump into the topic. The System Engineering Handbook, Chapter 5.4, is somewhat of a long chapter, and there's a little bit of redundancy, I think, in the chapter. So we're going to treat the high points. The purpose of project risk management process, according to the handbook, is to identify, analyze, treat, and monitor the project risks continuously. So we want to build a project plan. We want to know what the risks are in the project plan. We want to identify them, analyze them, and then we want to come up with mitigation plans. And then as the project is executed, we want to monitor and address any issues that occur. The chapter doesn't identify the project risks until late on, but here they are right up front. There are 3 risks to any project. The first one is you do not want to be over budget. You do not want to spend more money than you have. You do not want to be behind schedule. You do not want to deliver late. And then third, and probably most important, is you do not want to deliver a product or system that has poor quality or doesn't meet the technical performance requirements. So that last category in this chapter is classified or known as technical problems. So in plain language, the purpose of the risk management process shown in the orange text is to evaluate the project plan and monitor the project for events that can lead to three things: over budget, behind schedule, unacceptable product quality, and or unacceptable performance. So that's it in a nutshell. So just to kind of think through this issue of project management and risk, let's talk through a thought experiment. So the first set of bullets there, this thought experiment. The question: what would a project plan look like that had no or very low risk? So if you were to design a project plan and work on a project that had no and low risk, what would that project plan look like? Well, the answer is that you would want to take all of the risk out in three areas: schedule, budget, and technical performance. And so you would have a very long schedule. So no way you could be behind schedule. You'd have a very high budget so that you could never overspend. And then you would aim low. You would aim to have a very simple system. So of course, that's not practical. So this would result in an enormous amount of wasted time, money, and more importantly, you'd probably end up building a substandard product that the competition would beat very easily. So the reality is that no project can really be managed without risk. Risk is just an inherent part of organizing the schedule, defining the budget, and then designing the system to be competitive in the marketplace. So this is what we mean and what we want to think about when we talk about risk to the project. So the definition of risk, the first one that's listed in this page is risk is a potential problem to be avoided. So when we talk about risk, we want to identify a problem to be avoided. So there are two kinds of problems, or two ways of categorizing problems. The first one is the frequency of occurrence, so the likelihood that an event will occur, and then the consequence or the severity if that event were to occur. And severity is typically in terms of cost, schedule, or product performance. So risk, it has two components. It has likelihood that the event will occur, and then it has the severity or the consequence that the event will occur. So on the bottom of the page, we typically come up with a quantitative measure of risk as the probability of occurrence times the cost or the effect of the consequence. And one way to represent those is shown in the right-hand side in this thing called a risk matrix. So the horizontal axis is the likelihood of the event, the vertical axis is the consequence of the event, and when you join those two things together to confound them, you end up with these quadrants. The upper right-hand side is high cost and high occurrence. The lower left-hand side is low cost and low occurrence. And then the upper left is you have the low likelihood, but it'll have a big impact. And then the lower right-hand side is you have high likelihood, but there's low cost. And as a consequence, you kind of get these three regions of high risk, medium risk, and low risk. So for each risk that you've identified in your project, you want to go and see which area it fits into, and certainly mitigate the high risk and medium risk issues. So the risk to the project we've talked about is there are technical risks, schedule risks, and cost risks. The technical risks are to do with the performance of the system, and these can occur due to changes in the mission that the system is intended to operate in, unexpected complexity of the design, requirements incomplete, technology not feasible. So those are all kinds of technical risks that can occur. When a technical risk occurs, it typically impacts both schedule and cost, and that's the purpose of those orange arrows on the left-hand side. The schedule risk is the failure to meet deliverable deadlines and also intermediate project deadlines. And this can occur due to acquisition delays, deadlines, or schedule that's not feasible. And sometimes the project staff can be diverted by corporate or other things that could affect the schedule. So schedule risk or schedule changes always impact cost risk. And so that's the third bullet is you do not want to exceed your budget. So there are lots of ways that could happen, and one of the ways is that funding is delayed or project funding is cut. The System Engineering Handbook has this diagram on the right-hand side, and this diagram introduces the idea of programmatic risk. So programmatic risk is things that can affect the project from an organizational standpoint, affect the program. And some of those project funding is delayed or staff is diverted, also fit nicely into the schedule risk and the cost risk. But you should be aware that the handbook talks about programmatic risk as well. So the outputs, inputs, and activities. The input is the identification of what risks should be evaluated. You also want to know what events could occur. You're going to analyze the risks and then treat the risks and then monitor the risks. And at the end of the day, you want to publish a risk report with regards to the project plan and the execution of the project. So the question is, how do you come up with risks for projects? Well, you use all of the techniques that you would use to assess the risk of the product. You're treating the project as a process, as a system, and you use the same techniques to assess the risk. The ISO 31010 apparently has 30 techniques for risk assessment. Here's a couple that are listed in the handbook. Number one, brainstorming. Number two, checklists. And then there are kind of some more technical approaches, failure modes and effects analysis, fault tree analysis, simulation, and Bayesian net models. So just to make a comment on the first two, brainstorming by all means, very, very good approach. So one of the limitations of brainstorming is it's limited by our imagination. And specifically, we just don't know what we don't know. So brainstorming can only take us so far. Checklists are also very good, and and a very good way to ensure that we don't make the same mistake twice. So their kind of limitation is they're typically limited to past gotchas, things that got us in the past. Together, brainstorming and checklists are a way to come up with a good assessment, a good list of risks, and a way to assess them. All right, so the question is, how do you treat project risks? Well, here's the 5 standard ways of treating them. You avoid the risk, accept the risk. Number 3, control the risk, mitigate the risk, and transfer the risk. And together we can come up with an acronym of the AACMT. So avoid, accept, control, mitigate, and transfer. AACMT. Just a couple words on each of these. Of course, the complex subject deserves a video of its own. Avoid the risk, change requirements of design, do things to de-scope the project, put in schedule buffers, put in budget buffers. Number 2 is to recognize the risk and accept it. So you kind of do nothing and hope for the best. And related to that is come up with a contingency plan. So you're going to monitor things, and if the risk gets too high, then you're going to change course. Control risk, staffing, buffer, schedule, budget. One of the things that I think is very, very important is to start early. Don't wait, don't procrastinate. Get started early, and then use small teams with longer schedules. And the reason why that combination is the best, start early, small teams, longer schedules, is engineering is an intellectual activity. It's not manual labor shifting things around. It's about thinking. And intellect, it takes time. So you put people and give them enough time to think through problems, you've got a much better chance of success. And rather than having too many people thinking through the problems, you have a right-sized, small, focused group with lots of time to address issues. So start early, small teams with longer schedules as works best. Number 4 is to mitigate the risks. So you can outsource, you can partner, you can have parallel developments. I once worked for a company that was at a very competitive engineering environment, and it was not uncommon to set up 2 teams on opposite sides of the building and have them compete. Of course, when you do that, you're effectively doubling the costs, but that's a good way to manage the risk and also to incentivize the engineers to be creative. And then lastly, the traditional way of managing risk in society is to transfer the risk by means of insurance. So we are at the end of the video, and here's an opportunity to see what you know. So this is a place where you can pause the video, get a pen and paper, and see if you can answer these 11 questions. So when you're done, you can press play and go on to the next slide. Here are the answers to the questions. How did you do? So thank you for the opportunity to brief this video. This video covered the risk management process, and the next video in the series will cover configuration management process. If you liked the video, we'd be grateful if you could share it with others and also give us a thumbs up. Thank you.